Hello, this is Hamuz Rahman, and this is the second phase of our Discrete project. And I will be talking a little bit about what our project is. It is about graph isomorphism, which means that we will be detecting and manipulating smaller graphs in large target graphs, which are called dynamic graphs because they are constantly evolving. For our project, we were provided with a code by Oberoi and his team who solved a prevalent problem. The traditional methods for detecting isomorphism fail because they cannot work in graphs which are constantly changing. What they do is that they compare the data at different time steps, but as a result, they fail in areas like traffic flow studies, in which the graph is constantly changing, cars are moving around, and similarly in areas like sports analytics, for example, passing patterns. However, Oberoi solved the solution by going for the snapshot based model. Basically, what it does is that it takes snapshots on different timestamps, and then the data is compared. And this is how he solved the problem of dynamic temporal changing graphs. Now, the rest of the problem will be explained, and the evidence for Oberoi's solution will be given by my member, Asad.
Hello everyone. Now I will talk you through the evidence of improved performance and the implementation details of Oppo's dynamic graph analysis algorithm. Oppo's team tested their snapshot-based algorithm against two popular methods using real-world datasets, and the results were outstanding. It processed dynamic graphs much faster than traditional approaches, which is critical for real-world time applications like traffic analysis or social media monitoring. Second, it handled larger and more complex graphs with ease, showing excellent scalability where the other methods struggles. These advantages make their algorithm a strong choice for analyzing evolving patterns in dynamic datasets. Second, implementation and inputs. We implemented the tested algorithm to match subgraphs in dynamic graphs. Here's how it actually works. It uses snapshots of the target graphs at specific timestamps rather than treating the graphs as static. Second, it includes inputs. The graph target, a large evolving dataset, the pattern graph, which is a small graph to match, and the number of timestamps indicating the graph's evolution over time. Here are the outputs and key findings. The algorithm generates a detailed list of matches showing how the pattern graphs align with the target graph across timestamp. For example, at timestamp 0, vertex V1 in the pattern match with vertex V00 in the target. It also provides a total number of matches, confirming the accuracy in detecting temporal connection with the static model overlook. In conclusion, Oppo snapshot-based algorithm is faster and effective in uncovering pattern in dynamic graphs, making it valuable tool for real-world applications. Now my partner Daniel will explain the rest.
While discussing the overview of Borges' research, he explores the temporal graph modeling to enhance sports analytics by examining player interactions and team strategies during matches. His approach captures the dynamic nature of team performance through evolving graph representations. Firstly, he uses graphlet profiles. The x-axis represents graphlets, small subgraphs that showcase interaction patterns, while the y-axis indicates their occurrence frequency. Spain, depicted in red, demonstrates a rich and varied graphlet structure, reflecting their dynamic, versatile gameplay. Conversely, Argentina, illustrated in blue, exhibits a simpler graphlet profile, suggesting a more predictable and rigid strategic approach. Transition profiles. Heat maps provide a visual representation of transitions between graphlets. Spain's transitions span a broader spectrum, underlining their strategic flexibility and adaptability to varying game scenarios. In contrast, Argentina's transitions are concentrated within a narrow range of graphlets, highlighting a more structured but predictable gameplay and style. The significance and implications follow that the Burgess research underscores the potential of dynamic graph analysis to uncover hidden patterns in complex systems like sports. His work alongside Oberoid's innovations in subgraph isomorphism detection showcases the practical application of advanced graph techniques. in solving computational challenges and offering real-world insights. These findings not only demonstrate the utility of graph theoretical approaches in optimizing algorithms, but also reveals their transformative impact in diverse fields, from sports strategy refinement to actionable intelligence in competitive scenarios. Such advancements pave the way for more comprehensive analytics in domains requiring real-time decision-making and adaptability. This is the following Python output. This is the code we wrote in Python, and this takes the data from the CSV file and processes the data into nodes, which form a graph. Thank you.